See, first of all, we'll see what is an angle. So before we see what is an angle, first let's see how an angle is created. Now let's take a circle. So this circle, you may take it like a birthday cake, and when you cut your cake, you cut it from the center to the circumference of the sides. So when you cut it like that, you get an angle. So an angle is created when you divide the circumference. Circumference is the outermost layer of the circle. You divide the circumference by the radius. So in birthday cake, you cut it from the center to the ends. So when you cut it like that, you get an angle called theta, and this is got when you cut the circumference with the radius. Fine. Okay. So we'll first see what is the total angle of the circle. So the total angle is circumference of the circle, which is equal to 2 pi r divided by radius of the circle r. So these two cancel and we get 2 pi. So total angle of the circle is 2 pi. Another way of measuring the angle is dividing the circle into any number of parts for degree measurement. Degrees we have, we cut the circle into 360 degrees. So this is the first part you are cutting, second part, third part, like that till 360th part you have to divide. So when you divide it like that, the angle is called 1 degree. Fine. So 360 degrees is the total angle of the circle, since you cut the circumference by 360 parts. Fine. Okay. Now we'll see what is the unit of measurements. When you measure it using the first method, that is 2 pi, you call it as radians. The symbol for radians is a crescent moon or half circle, whatever you want you can say. So next is the total angle of the circle in degrees is this symbol. Fine. Okay. Now we'll see how to convert a degree to radian and a radian to degree. So the first thing is, we see that 2 pi radian is equal to 360 degree, since this is the total angle of the circle. Fine. So we write 2 pi radian as 2 pi into 1 radian, which is equal to 360 degree. So what is 1 radian now? 360 degree by 2 pi. This is a very important formula. You can write it if you want to. Now, next, 360 degree can be written as 360 into 1 degree, which is equal to 2 pi radian. So, 1 degree is equal to 2 pi by 360. So, this is how you convert 1 degree to radians. Fine. We'll use this formula now. So let's say I want to convert 90 degrees to radian. Fine. So 90 degree is 90 into 1 degree, which is equal to 90 into 2 pi by 360, which means it is 2 pi by 4, which is equal to pi by 2. So 90 degrees means pi by 2 radian. Now let's say pi by 2 radians to degrees. So pi by 2 into 1 radian, we can write it is equal to pi by 2 radian. So which is also equal to how much? Pi by so pi by 2 into 1 radian equal to pi by 2. Instead of 1 radian, I'm going to write 360 by 2 pi. So what happens is we get 90 degrees. Now, one thing we have to remember is that the trigonometric ratios are available only for the right angle triangle. So, if you have an equilateral triangle or a scalene triangle, you have to divide the triangle into two right angle triangles. For example, I'm having an equilateral triangle. I cannot ask for the sine theta of this. Instead, I can divide this whole triangle into two parts and say this is theta 1 and this is theta 2. Same in case of a scalene triangle. I can draw a perpendicular bisector and then talk about the trigonometric identities. Now, if I can also draw a perpendicular bisector to any of the sides, that is, there are three sides from which I can draw a perpendicular bisector and call them theta 1, theta 2, and still theta 6 I can call them. This is theta 3 and this is theta 4, this is theta 5 and this is theta 6. So we don't want to go into complexities. We'll just maintain that if there is no right angle triangle, we cannot call for the trigonometric ratios. Now we'll talk about what are the trigonometric ratios. Before that, you're all having any doubts regarding the previous video, drop a statement in the comments. The most frequent doubt you're asking is why should an angle be set in radian and not in degrees? So most of the computation we'll be doing in only radian. The meaning is that, see, if in degrees there is no such rule, why you have to divide these parts only in 360 parts? For example, I can individually divide each of the segment into another 60-degree. So that will be making it, there's no logic in saying why should I be doing it only dividing the circle in 360 parts. Now I can divide the same circle into 720 parts and call it a different name. So this anomaly is corrected only when we do it in terms of radian. For example, I cannot say 360 degrees, uh, theta is equal to 360 degree. Now another new measurement can call it as 360 nu. This is a new unit which I have invented. So 360 degree is equal to 720 nu. So it's a new unit. So I don't have any particular logic for say confining it to 360 degrees. Whereas when I say theta is equal to 2 pi, which is also another way of saying 360 degree, pi has a important value, that is unchanging value 3.14. Fine. Pi is a rational number and it will go on like 3.4 something, it will go 7 2, it's a rational number, but I can approximate pi into 3.14. So when I make a measurement of 2 pi, I mean it as 2 into 3.14, which is equal to 6.28. Now this is a standard value. Fine. So when we do computations, that's the reason we are doing it in terms of radian, because pi is 3.14, which is a standard value. It doesn't change, but it's an approximation since pi is a irrational number. Fine. So we'll, after all these, we'll be going into definition of uh, the trigonometric ratios. So take a right angle triangle, any angle. So the longest side will be called as a hypotenuse, the shortest side will be called as opposite, and then the other side will be called as a adjacent. Fine. So this is hypotenuse. Opposite to hypotenuse is the opposite side, and then the other side will be called adjacent. Now take a angle called theta. Fine. Now many of you will be having doubts like, uh, we are having a circle and an angle is confined to the circle. Now how come we do talk about a angle in a triangle? Now, if you have such doubts, drop a perpendicular bisector from the closing end of the angle, and now you have 90 degrees. So this is the theta and the diagram we are having here. Fine. For a better diagram, I'm drawing a circle. I have two radius divided by two radius r. I'm dropping a perpendicular bisector. Now this triangle is the triangle we are talking about here. Clear? Okay. Now sine theta is equal to, now we have O, H and A as the short form for this measurement. Sine theta is equal to opposite by hypotenuse. Now the inverse of sine theta is called cosec theta, which is equal to hypotenuse by opposite. Cos theta is called as adjacent by hypotenuse, and inverse of cos theta is equal to sec theta is equal to hypotenuse by adjacent. So this can be written as 1 by sine theta. This can be written as 1 by cos theta. Now tan theta is equal to opposite by adjacent, which can also be written as opposite by hypotenuse, adjacent by hypotenuse. Hypotenuse cancel. Hence we get sine theta by cos theta. The opposite of tan theta is cot theta, which is equal to cos theta by sine theta, which is nothing else but adjacent, hypotenuse by adjacent divided by hypotenuse by, oh I'm sorry, cos theta by sine theta equal to adjacent by opposite. Clear? So these are the trigonometric identities. I mean trigonometric ratios. Fine. So these are trigonometric ratios, and I'll just make a table of this so that you can have a better view. Sine theta is equal to opposite by hypotenuse. Cos theta equal to adjacent by hypotenuse. Tan theta equal to opposite by adjacent. And similarly, cosec theta is equal to hypotenuse by opposite. Sec theta equal to hypotenuse by adjacent, and cot theta equal to adjacent by opposite. Fine. So these are trigonometric ratios. Now we have three important identities. They are sine square theta plus cos square theta equal to 1. We'll see it how. So this is theorem. We'll see the proof now. Sine square theta is equal to opposite by hypotenuse square plus adjacent square by hypotenuse square. Now, from Pythagoras theorem, we know an important identity. This is hypotenuse, opposite, and adjacent. Pythagoras theorem states that hypotenuse square is equal to opposite square plus adjacent square. That is, the longest side of the triangle square is equal to opposite square plus adjacent square. Now you have to remember an important point. It is not equal to opposite plus adjacent whole square. This is not equal to this, for this will mean o square plus a square plus 2oa into 2o into a. Fine. This is not equal to hypotenuse square because of the adjacent extra term 2oa. So it is not whole square but individual square. So now using Pythagoras theorem, we can say o square plus a square by h square, and from Pythagoras theorem we have this as h square plus h square equal to 1. So this is the proof of that statement. Now next is sec square theta is equal minus tan square theta equal to 1. So it's the same proof we are having, h square by a square minus o square by a square, which can be written as, what can we write for h can be written as o square plus a square minus o square by a square and by a square. So I have simply written expansion of h square there. So which comes as o square plus a square minus a square by a square. Oh, sorry, this is o square, right? O square. So o square and o square gets cancelled, which means a square by a square equal to 1. The third proof is the third proof is cosec square theta minus cot square theta equal to 1. So we can write this because cosec square theta is equal to h square by o square minus a square by o square, which is equal to h square can be written as o square plus a square by o square minus a square by o square, which can be written as o square minus a square plus a square by o square, which is equal to o square by o square equal to 1. So this is a proof of these theorem. So these three formula are called trigonometric identities. Identity is something when you get when you equate two things. So I'll just write it as a table here. First thing is sine square theta plus cos square theta equal to 1. Second is sec square theta minus tan square theta equal to 1. Third is cosec square theta minus cot square theta equal to